Hi, welcome to the Calculus 3 lecture series. We are still in the unit vectors and the geometry of the space. And we are right now, excuse me, we are right now in the lecture number 5. So in this lecture, we're going to talk about how to find the equations of lines and the planes in the R3 space here, okay? So we're going to divide this lecture into 2 videos. So the first video, we're going to talk about how to find the equations of the line in the R3. And then the second video, we're going to work on how to find the planes. Okay? Okay, so now let's go to my worksheets. So let's start. All right. So before we before we start to do some problem, let's take a look. In the R3 right now we want to find the lines, right? So let's kind of a flashback when we were in the high school. We talk about the geometry in R2. So how do we find a line, right? So in R2, so in the geometry, we said we always, the one of the formulas here, we said we can use the slope and 1 point, right? So you give me 1 point, and so if this is x1, y1, right? So if you give me a 1 point and you give me the slope, then I can know what is my lines looks like, right? So like in here, so that's why if you have lines, go like here, right? So for these lines here, if you're passing through this specific point, x1, y1, and with the slope, let's say the slope is here, slope is n here. So now we all know the formulas here we do. So that means for any points, right? So for any points in the xy, so in order to represent this line, so what is the formula is? We said is y minus y1 equal to the slope of x minus x1 here, right? This is, we call this the slope and the intercept form. Okay, now let's take a look in the R3. Right now we expand in the R3 here. So how do I find it? I don't have the, so right now I have x, y, and z here, right? So let's take a look at these pictures here. Okay, so here, this is my x, y, and z. So this is my x, y, and z axis. So I have lines here. Okay, so this line is in the space here, right? So we have these lines here. Right? So I have this line. Okay, so these lines here. Okay, so this is the line in the space. And we say the same thing. This line, we know in order to define the line, these lines, right? So we say, okay, for this line, we know this line goes through a specific point, right? So let's say here, this line goes through these points here. Okay, so this is the points, just like we talk about x1, y1 here, it's the same. This is x0, y0, z0, right? So this is the point. This line goes through here. Okay, and now in here, and so let me write this point. So it's not too crowded here, right? Okay, so like this one's here, we say this is the point x0, y0, and z0 here, okay? And now in here we say, okay, so this line going to pass in this point here. And also, right, like in R2, you need to know which direction this line goes, right? So this, that's why in R2 we have a slope. So for in here, we say, okay, this line go these directions, right? So I'm going to have and vectors here. This vector, I said this is what I call the v vectors here. Okay, so this is the v vector. And the v vector is made of the A, B, C points, right? So this is a vector A, B, C here. So that means A, we go in the direction of the A, X equal A, Y equal B, and Z equal to C. So this one parallel to the given lines here. So this is what I call this the V vector, because this line going to parallel to this V vectors here, correct? So this V vectors here, that's what we call it. This is the direction. Okay, so this is we call it, this is a direction vector. So it's the very similar concept like the slope, but this is the direction vectors here. So like the name here is A, B, C, like those are the directions. What are those things here? This we call this direction what? Direction numbers here. Okay, so now let's do the same things here. If you have any points in the lines, on the lines here, right? So here, let's say in general, if this is the X, Y, Z here, all right? So in general, if this is X, Y, Z, so in R2, that's how do I write is Y minus Y1 and equal to the m the x minus 1. Okay, so now let's see how do I do this ones here. Okay, so in here, so for this point, x0, y0, I can create a vector, right? So this vector, this is my vector. So this is, I call this what? I call this is the R0 vector, all right? So this is, I call this the R0 vectors here. And now, okay, so this is a V vector. So I know because the V is parallel to here, so I know for every, any points here, right? So you can always, right? So you can always, let me see, how do I do this by the color? Okay, so for any point X, Y, Z here, you can always kind of like the generate a parallelogram, correct? So, and this parallelogram and the diagonal of this parallelogram, like here, right? So the will be what? This diagonal, that will be the, so this is how do I define the lines, right? So this is, I call this the R, right? So I know the R is always equal to the diagonal, is always equal to sides here, right? So it's R0. Okay, so it's R0. Okay, so let me put the 0. I should put the 0 in the bottom here, right? So it's R0 and the plus, right? Plus, so plus this factors here, plus this factor. So this vector is a part of the directional vectors, right? So, but the x, y, z can be anywhere. So that's why what I'm plussing here, I plus the t times what? T times v here, right? So like in here, so t could be 1/2 because this is the v's, right? So that's why this is what I call it is the vectors form about the line. All right, so let's take a look. So this is the vectors form. Okay, so this is a vectors form. How do we define the line? So what is R0 here? R0 is the vector, the point, this line going to go through. What is the V? V is the directional vector. So it's very similar like here, right? It's a point and a slope, right? But here we call it the directions here. So now if you kind of write it out, then here you will see here, so what is the R? R is any point X, Y, Z, right? So you will say this is X, Y, Z is equal to, what is the R0? Is the point you go through. So it's Y0, Z0, right? And the plus the T, that's the parametric parameter. So t can be any numbers, right? Okay, so the now in here now, let's see here, that will be, okay. So so this will be this color, no, this color, all right. So this one's here, the t will be, so t will be any number, and the v will be our directional vectors. Okay, so the v is our directional vectors, right? So that's why it will be A, B, C here, correct? Now you can put it like this way. See here, we say x is equal to x0 plus ta, and y is equal to y0 plus tb, z is equal to z0 plus tc. And like I said, the t here, right? So the t here, this is the parameter. So this is what we call the what? This is what we call this a parametric form. Okay, so this is a parametric form. How do we write x, how do we write a lines, right? So the line is x, y, z. So this is a very similar, like the slope intercept form, right? So similar like that, x equal to the x0 plus ta, because the a here is what? Is the directional. So it's kind of like the slope, right? Then y is the y0 plus tb's, right? So it's kind of like the slope for the b. I mean, the kind of like it's not really, so don't want to use the word of the slope, but this is what we call it is the directional vectors, right? Directional parameters here. So this is the parametric forms here. So we have two forms, right? So here, this is the vector forms. Then we also talk about the parametric form. And then the last things here, you can see here, right? So if you do a little changes here, so this one's here t, you can say the t is equal to what? X minus x0 divided by a. And this one's here t is equal to what? Y minus y0 divided by b, and the t is equal to what? Z minus z0 divided by what? Divided by c. As you can see, they are all equal to t. So that's why I can write it in here is xx minus x0 over a is equal y minus y0 to the b, and is equal z minus z0 to the c. And what do we call these ones here? These forms here, we call this a symmetric form. Okay, so we have three ways to write a line in the R3s here. All right, so I said the concept-wise is pretty similar, right? So you need to pass in through a point, then you need to know which directions here. Then we just use our the vectors addition to find the lines here. Okay, so take a look. What is the definition we just went through here. I hope you understand. And so remember, we have the vectors form, parametrics form, and the symmetrics form. All right. Okay, so now let's take a look. Let's take a look at how do we do the problems here. So let's say the number one is here, find the three form for the line. This line goes through 416, and this line is parallel to 730. So 730, this is a what? This is my direction vectors, right? Okay, so by the vectors form, so let's take a look at vectors form. Okay, vectors form is VR, right? So it's R is equal to the R0 plus T V. So that's why we say the R0 is what? So the R0 is 416, right? So the 416, so plus T times the V. So this vector is the V vectors, right? So it will be what? Is 4 plus what? 7 T, and then here is 1 plus what? 3T, and what? 6, right? So that's a vector. So if you want, you can write it as 4 plus 7t, the I, plus 1 plus 3t, the j, plus 6k. So that's what we talk about is the vectors term. Now, let's take a look at the parametric term. Okay, so the parametric terms here, so it's x, y, z's, right? So x is equal to the x0. So this is the r0, right? That's the point that goes through. So it's a 4 plus what? 4 plus 17. And the y is equal to what? 1 plus what? 3t. And what is z here? Z is just what? 6, right? So it's 6. Okay, now let's do the symmetric term. Okay, so the symmetric term, so I know the x minus 4 over 7 is equal to y minus 1 over 3. But z doesn't have a t, so I need to write z equal to 6 here. So this problem here is kind of very mechanical problem, show you how do we write the line by using a 3 different form to write our line in the R3. A lot of people, they have a, I think a lot of people, it's kind of like very difficult to visualize it, you know, say, what? This is a line, all right? So yeah, it is a line here. Okay, so now let's take a look here. So I want to find the vectors, you know, I want to find the vectors form to the line passing through 2 points here. Right now, they give you these 2 points, all right? So how do I do it? So if you take a look at these ones here, right? So that means if you have a pointer number 1 here, pointer number 2 here, I don't know if this is right or not, but this is, for example, this is AB's, right? So you have 2 points here. Okay, so you have 2 points. All right, and now, okay, so remember, right, we need to have a, so this is a line goes through these 2 points, point A and the point B here. So the first things here, remember from the, here, we need to have x, y, z's, right? So x, y, z, that's the any general, you know, so this, you know, this one's here, right? So it has to be parallel. You know, we need to find the directional vector. So first, let's try to find the vector of A, B here, right? So the AB here, so we say that this vector from the A to B, right? All right, so A to B, it will be 12 minus 5 and 6 minus 9 and 10 minus 7. What is here? Have a 7, negative 3, and what? And the 3, right? 7, negative 3, and 3. What is this one? Because this one we just did is this. We did this segment, right? We said this is the vector, right? We did this segment. So I know from previous, so I know what is here. My directional vector has to be parallel to here, correct? So in fact, this will be my directional vector, this here. So now after I have the directional vector, then I can use the vector form. So I will just say R is equal to the R0. I can use my R0 is 5, 9, 7, right? So I say it's the 5, 9, 7, then plus the T, right? 7, negative 3, and the 7th here, right? So that's what, you know, that is our lines here, right? So remember, just like in R2, a line, we need to have a point and we need to have a direction, right? So we need to know where it goes. Okay, now let's take a look here, right? So determine whether the line L1 and L2, they are parallel, intersect, or skew. Okay, skew, that means they will never intersect, and but they are not parallel. Okay, So now let's take a look here. The first one's here, the line ones, right? So remember, this is a parametric form. So what is my V, or this is my direction? So this is my direction vector. So where is this line, the direction go? So go what? 5, 4, and what? 5, 4, and 1. That's right. And what is this one's V's go? This is the, okay. So the direction, so this is the 5, 4, 1. So this is the direction, right? So for here, this one is the direction vector. So what is this direction vector? Is 3, -1, and 2. So if you compare these two direction vectors there, right? And they are not multiplied by a constant. So I say V1, V2, right? So V1 is not equal to a constant times V2, right? So now I know L1 and L2 is not what? Parallel, right? So they are not parallel here. Okay, so now let's see. So the first thing we come to conclusion is not parallel. Okay, so the next thing we want to see is they are intersect or not. What do we mean intersect? You know, just like in the geometry, we say L line 1 equal to line 2. That means X need to be equal to the X and Y equal to Y, right? So that means 1 plus 5t it has to be equal to the 10 plus 3s, right? Because the two lines intersect, that means the x and the x going to, you know, the x, y, z on this line have to be equal to the x, y, z on the other line, right? So x is 1 plus 5t in one line, 10 plus 3s in other line. So this is 3 plus 4t has to be equal to the 17 minus s. And now this one here is -2 plus t has equal to the -3 plus 2s here. Okay, so now let's try to solve. So basically we want to see is there a solution? So we want to solve for s and t. So what I need to do here, I guess I solve the system of equations. So I times what? I times 2 on both sides, then add to the, you know, then add to the third equation. So times 2. So this is 6 plus 80 equal to the 34 minus 2s. Now I add to the third equation. So this is -3 minus 2s plus 2s. So this one cancels, right? Okay, so this one cancel, and then this is the 4 plus 90 is equal to what? 4 plus 90 is equal to 31. So that means 90 equal to 27. So t is equal to 3. All right, so here we have a t equal to 3. Now, after I have a t equal to 3, I substitute to find the s. So -2 plus 3 equal to the -3 plus 2s. Okay, so s equal to what? I solve it, and s equal to 2, see here. Okay, so s equal to 2. So I use these two equations to solve the s and t. Now I need to substitute back to the first ones, right? So I need to substitute back to the first one to see is it true or not. So t, so it's 1 plus 5 times 3. So the left-hand side, this is 16. If this is equal to the right-hand side, so it's 10 plus 3 times 2. Arbitrary, this is equal to the 16. So what is here? So yeah, they are equals, right? So when they are equals here, then what's that means here? So when they are equal, that means we have what? So that means we have a solution. That means these two lines what? These two lines intersect. All right, okay. So that means these two lines intersect. You know, if they are not parallel, they not intersect, then they have to be skewed here. Okay, so now let's take a look at the next, right? So find the equation of the line. Okay, so this is pretty mechanical also. I want to find the line parallel to the line L and through the given point. Then use the same form, whatever, you know, your problem given. So this is a parametric form. So I said find the passing through this point. Okay, so this is easy, right? So this one's here because what? What are those numbers? Those are the directional number, right? Directional vectors numbers here. So, okay, so what is my answers here? So the A equal to 5 equal to -2 because they are parallel. Now it's passing through this specific point. So I just say x minus 4, y minus 5, and z minus 1. See here. All right. Okay. So now let's take a look the next ones here, right? So the next ones here, we say the R equal to 3 plus 4t minus t and the A plus t case here. Okay, so let's see here. Where is my directional vectors number? Is this number, right? So it's this number and what? And this number and this number and these numbers, right? Okay, so now let's try to write it, all right? So here, because it's the same way, so I know these are, okay, so this is the, let's say the R prime is the one parallel to the R. So instead of -3, so we know this, those numbers, we know those numbers are what? Those are the point, right? Okay, so now let's try to write it. So what is here? We replace, so it's -1 plus 14 I, right? Now what is the second one here? It's 3, right? So it's 3, but I have a minus t here, minus t, the j. And what is the third one we replace to? 2 plus t to the k. So it's pretty straightforward, all right? All right, so the now number C is here. So what, so this is, oh, I'm sorry, this is a symmetric form. This is a parametric form. So parametric form, first, let's recognize the where is my directional vector here, here, and here. Okay, so now this one is pretty easy to do. So what is the answers here? So x equal to what? 7 minus 90. Y equal to what? -3 plus 3t. And z is equal to what? 2 what? I'm sorry, it's not a 2, it's the new point, right? So it's a what? It's a 5, right? So it's a 5 plus 4t, right? So they all have the same direction, right? So -9, 3, and 4. Okay, so now okay, so here, before we finish this videos here, so the last problem is, so they say, hey, can 3 lines, right, draw, so 2 of them, that any 2 of them are always skews here. Okay, so in fact, this one is pretty interesting. The 2 of them is always skewed, right? So let's take a look here. Okay, so let's see what is the skew. So here, this is the z-axis, and this is the y-axis, and let's say here, this is the x-axis here. Okay, let me try to do a first one here. let's see here. This is 1, 2, 3, 4. 1, 2, 3, 4. That's right. So let's do first one is 1 and 2 here. This one, see here. Right? So I'm drawing a line. See here. The red one goes through, punches through the XY planes and the parallel to the Z axis here. Okay, so I can do another lines here. 1, 2, 3, 4, 5, 6. Let's try to do another one. I say 1, 2, 3, 4. I do a one, goes through the Z, right? So goes through the Z axis, right? And parallel to the x-axis. Okay, so now I can do the other ones here. Okay, so let's say here this is the 3s, right? So this is the 3 here. Now I go to do a line here. Right, so can you visualize that? So any two of these lines, they are skew. So for example, the red one and the blue one, so here, right? So the red one and the blue one, they are not parallel, but they're not going to touch. In my graph, it's kind of like they will touch, but it's not, right? Because they're going to go through the XY plane at the, when the x equal to 1 here. So basically, if you want to, so this is not really go like this, right? So this one's here is kind of like, then this part is going down, right? So it's going, kind of the goes through, goes through the XY planes here. That's when the blue one and the red one is not going to touch here, right? So the same way is here for the blue ones here, this one's here, really, it's going through like this one. If you see the dotted lines here, that's why they kind of pass, kind of parallel to the Y, but in here, this is, so the blue one and the green one, they are parallel. So this type of lines we call the skew, right? So the any two of them, they are skewed to each other. Okay, that's it. So like right now we're going to stop here so we know how to write a line in the R3s, right? So in the R3, so that refresher, what do we learn? We have three forms: the vector form, parametric form, and what? And symmetric form. Also in the R3, if you remember in R2, if you have two lines, you only have two situations. They either, right? They either parallel or they're going to intersect. When I means parallel, of course, that means if they are the same lines, we have treat it as a parallel, or they're going to intersect. So, but in the R3, we have one more situation. For R3, any two lines, we can have three situations, right? They are either parallel, or they intersect, or what is here? They are what is skew, right? So make sure you understand the differences here. Okay, that's it. This is our first video for this topic. How to find the line in R3 is quite unique, right? So it's kind of like a similar concept in R2, but the form is kind of totally different. All right, that's it. Okay, so nice to talk to you, and let's looking forward to talk to you in the next video, how to find a plane in the R3. Okay, bye. Have a good day.